Chapter number 3. This is motion in a straight line. We are discussing motion in a straight line. Very common phenomena. Something is static or something is dynamic. That means moving or non-moving. So motion is common to everything in the universe. While you are walking, running, cycling, your blood circulation in the body, the flow of water, the flying birds, these are the examples which you will encounter or see in your daily life. Some motions may be invisible, that is the random motion of gas molecules we won't be able to see. The electrons flowing in the conducting wire, again, they are invisible. So stationary looking objects like the roads, trees, buildings, these are in motion with Earth's rotation. And also the Earth would revolve around the Sun. So if this is says Sun, then Earth would revolve around it, and simultaneously it will rotate on its axis also. So this revolves around the Sun, and the Sun itself is moving or in motion in Milky Way. And Milky Way is also in motion with respect to other galaxies because we are in Milky Way. So we can say that everything in the universe is moving. So when any object will change its position with respect to another object, that is, if this is an object, this is an object, and this is moving with respect to this object, we say that this object is in motion. And motion can be of various type. It can be linear, it can be rotational, it can be vibrational, like the oscillation. You have seen the pendulum. So we will confine and we will discuss about the straight line here, which we also know as a rectilinear motion. So we'll try to understand the displacement, the velocity, and the acceleration. Kinematics and dynamics. Now the branch of physics which is dealing with this motion without even considering about the causes. So dealing with motion but not able to just not considering the causes, these are known as kinematics. But that branch of science which describes the motion, something in motion or moving, along with it, the causes are also being investigated, the properties, the causes of a moving body, and this is known as dynamics. The kinematics and dynamics, they both are combined, and collectively they are known as mechanics. So in this chapter we'll discuss only about kinematics. What is the concept of a particle? Particle, anything, we take a car as an object, or a bicycle as an object. So we will treat the object in motion as a particle. A particle is a point-like object which is having certain mass. It is endowed with some mass, and they must have some dimension. But in certain scenario or situation, the circumstances, an object can be treated as a particle. What are the circumstances? First is, all the particles of a solid body, they perform linear motion. They would cover the same distance at same time. So motion of these bodies, this can be described in terms of motion of any of its constituent particles. So if this is an object, these are the particles. Any particle inside this, and this whole as a particle will cover the same distance at the same time. If the distance between two objects is very, very large, as compared to their dimensions, then these objects will be known, and in the mostly in the computation level, we will compare, or we will say them that they are very small, or they are just particles, point particles. For instance, the calculation of gravitational force between, say, Sun and Earth, both of them can be considered as particles because the distance between them is very large as compared to the dimensions of these objects. Frame of reference. Frame of reference is very important, and you are free to choose any frame of reference. The question is, before we start about discussing frame of reference, the question is How do you know that object is at rest or in motion? Here is an example. We have a train and we have a bag here, say, right? Here's a bag. Now, you are here somewhere. The train is moving with some speed, and there is another person here. Say some trees are here. Now, for this guy, and the train is moving. For this guy, this bag is stationary. For this person, because this train is moving, this bag is in motion. For this person, because he is standing along the tree, for this person, this tree is static. It's not in motion. Yeah? It's not moving. But for this man, or for this man, this tree is moving. So it all depends on the scenario and the frame of reference. A person in the train would find the bag stationary, as I said. But the person who's standing by the roadside would find this bag in motion. So it is observed, this bag is observed from the train. It is in motion. He is observing it. He is observing it. But if you observe this tree, the building which is outside, they are stationary. They are stationary. But as we observe from here, but as the train is moving, the person here would see them as in motion. So motion is a combined property of the object which is under study, that means this object, along with the observer. Where is the observer? Who is the observer? In other terms, we can say that motion is a relative concept. You understood this? This is a relative concept. So let us say that a place and a situation from where an observer takes or looks at the object or take the observation, this is known as frame of reference. In this example we discuss the bag, the frame of reference of the passenger is the train moving with a constant speed, while the person who is standing outside on the road, the frame of reference is not train but earth. So the frame of reference can be of two types. One is inertial frame of reference and the other is non-inertial reference frame. We'll discuss about that in the later discussions. Position, path length and displacement. Let me ask you a question. You started from here, you went to uncle, you went to auntie, you went to your grandfather, and then you came back. How much distance have you covered? What is the position you have at different time? And what is the displacement? The answer would be that the distance is from here to here to here to here. Let me say 1 kilometer, 2 kilometer, 2 kilometer and 5 kilometer. So the distance you covered is 1 plus 2 plus 2 plus 5. That is, it is 10 kilometer. But what is the displacement? Because at initial from here you started, then again you came back here. So the displacement is according to your position. You haven't displaced. You moved a lot, but you came back again to the same position. So your displacement is 0. Now this seems to be somewhat new for you, but we will discuss and you know that what is the distance and what is the displacement. So to locate the position of a particle, we always need a frame of reference. We cannot just say that this is a position. From where it is related, from where you are watching. So there is no rule or restriction on the choice of frame of reference. You can take any frame of reference. We can select a reference frame according to your convenience. It's up to you. Normally we choose this. This is X, this is Y, and this is Z axis, Z axis. Now any point, say here, 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 you can always find the X distance, Y distance and Z distance, and you can say, okay, this is the X, Y, Z position, X, Y, Z position of that object. Now you have a frame of reference. This is a reference point. You can start with this. This is a 0 reference point. And along the axis Y, or you can say along XY planes, YZ plane and XZ plane, you can easily point a value. The coordinate XYZ of a particle will describe the position of any object with respect to its frame of reference. This is known as coordinate system. So according to this reference, or you can say coordinate system, the position can be easily obtained. Now you started from here, say in time 10 minutes you reached here. In 20 minutes means in 20 minutes you reached here, so you took 30 minutes to reach here. So this is T1. At time T1, your position is this. At time T2, your position is this. T3, your position is this. Likewise, we will understand. And at this was T0, and again T5 is here only because you came here back. T4. So this is all the way in which we are going to deal with different aspects of your path length and displacement. So here is an idea. You were here, x1, y1, z1 at this point. Now at T1 you reached here, means you followed some distance, you followed some path, and at point B at x2, y2, z2, that is the x distance, y distance, z distance from the coordinate system or origin, you are here. So this is from origin and this is again from origin, right? So this is a position of a particle in frame of reference, which is our x, y, z coordinate. So in this scenario, the position of coordinate of a particle in motion at time T1 is x1, y1, z1, and at time T2 it is x2, y2, z2. So this shows the position of particle with respect to given frame of reference, which is your x, y, z coordinate system. If all the three coordinates of a particle will remain unchanged with the time, then we say that the particle is at rest. That means x is 2, y is 0, and z is 2. This is x, y, z position. Now with this is at T1, you say at T2, you are at 2, 0, 2. Again, now neither of x, y or z has changed. That means you are at rest. If one or more coordinate of a particle changes with time, then we say that the particle is actually moving. If any one, say this one, or this one, any of one coordinate changes with time, then we can say that it is in linear motion. When an object is in linear motion, when any of these x, y, z, any one of these, only one of these position changes, other remains the same. If we have an object which is falling freely from top of a tower, the motion of a car along a straight road, these are example of linear motion. Now, when two or three coordinates, means not one but xx, yy, or say xyz, so two or three coordinate change with time, the motion of particle is called two dimension, because one dimension has changed, linear motion. Two dimension change, we get 2D motion. When three dimensions have changed, we can say that these are three-dimensional motion. The earth which revolves around the sun, the striker moving over the carom board, these are 2D motions. But a butterfly, the butterfly is free to move in any direction, any way. So the butterfly may be changing all the x, y, z position. Then we say that the butterfly is moving or flying in three-dimensional motion. Let us describe the motion along a straight line. We will choose an axis and say this is an x-axis. Why we are choosing only one axis? Because in a straight line motion, only one of the coordinate change. Say x is the direction in which the particle or the object is changing its position or moving. So it coincides with the path of the particle, this x-axis we have taken. Now we can decide the position of a particle with reference to some origin. Okay, this is the origin, we have taken this. Now the position to the right, we will take it as positive, and if the object is moving this side, we'll say it is in the negative side. Okay, here positive, here negative. Now in this scenario, what is happening? The object is not starting from the origin. The object is starting from the position A, that is already 20 km ahead of O. Now the object has taken or is in motion and it moves to B. So how much distance it has traveled? 20, 80, that is 80 minus 20, which is 60 km it has taken. At 80 it turns back, it moves back till it stops to point C. Now again in the opposite direction, because this is 60 it has taken, in the opposite direction from here, if we say it is 60, now again it is coming back, so it has to be in the negative direction. So 80, 40, how much distance it has traveled from 80 to 40? It is 40 again, but it is in negative direction, right? So this is the scenario we will be going to take in various discussion from now. So what is the path length? The path length is the total distance traveled by a particle in some time interval. This is called the path length or total distance. Which how much you have traveled is computed totally, and that is the path length. But the displacement is something different. That is the change in position of a particle in some time interval. This is the displacement. So there is a difference. If x1 and x2 are the initial and final position, and this x1 is at your position at t1, x2 is your position at t2, then the displacement in time interval, that is t2 minus t1, delta x, the displacement will be simply final position minus initial position. We are not worried about the in between positions, only final and initial. You can say that I move from here to this point, right? So the distance is totally this plus this plus this, but the displacement is this one. This is the change in the position. If you try to find out displacement in this position, it will be this distance. Displacement from this point to this point, this will be this one, and this one I already told you. So displacement is different from the distance. The SI unit of both the path displacement and path length and displacement, they are known to be carried out in meter. So let us again talk about the difference between distance and displacement. Now the time interval was t2 to t1 in the discussion we had. The path length was what? Let us see. From 20 the object moved till 80. So what is the distance? That is 60. Now again it moved back from 80 to 40. What is the distance covered? That is 40. So 40 plus 60, this is the total distance covered. So 100 is the correct path length. But what is the displacement? I'll take you again to the diagram because displacement has to be understood. Displacement is, it started from A and then came back to C. So ultimately from A it started, and after moving somewhere it came back to C. So this is the only path displacement. So 40 minus 20, that is, it is 20 kilometer displacement. So I hope you have got the idea of distance and displacement. So path length and displacement in this case are both positive. Displacement is directed in the positive direction if the car starts from B to C, as you saw in the figure. So path length was 80 minus 40 and displacement was 40 minus 80. In this case the displacement was 40 minus 80, so it is minus 40 kilometer. The displacement can be negative. Distance will not be in negative, but displacement can be negative. So displacement of car is in x direction, and in the example we have seen car starts from A, goes to B, return to A. The total path length was actually 120, but the displacement is just 0, because if you say it starts from here and comes back to this point, then the total distance will be 120, because from this is 60 and again this is 60, so 60 plus 60 is 120. But this is A, and say the final position is say C, and it came back, A and C are in the same position, that is the displacement is 0. So path length is always positive, while displacement can be either positive or negative or 0. Okay. So displacement is just the resultant effect of motion of car from where it started and where it ended. This is displacement. And displacement both have magnitude, as you see, this is magnitude, and also the direction. If you landed here, this is the magnitude, but this is the direction. These are the directions, and these are represented by vectors. We'll learn about these vectors shortly. So in one dimension motion, there are only two directions. It can be either this way, or either this way, that way. That is backward, forward, upwards, downwards, in which the particle can move. And if we take this as plus, we have to take this as minus. If we take this as plus, this is minus, and vice versa. So a particle moves along a circle of radius r. It starts from A. In anti-clockwise, that is in the opposite way the clock moves. Calculate the distance traveled by the particle and the magnitude of displacement of each of the following case. So from A to B. Now A to B. Before we discuss about this question, first is a circle, and we know that the circumference of a circle is 2 pi r. This is 2 pi r. Now this is the 1/4 of 2 pi r. So this will be 1/4. The distance will be this one. How much is this from A to C? This is 2 pi r by 2. So distance will be this. How much about this? This is 3/4 of a 2 pi r, right? Yes, this is 1/4. 1/4 of 2 pi r, so this is 3/4. And how about this? If it starts from A and come back to A, what is the distance? This is complete 2 pi r. So these are the distances. Let us know the displacement from A to B. Now the displacement is this one, not this one, but this one. So this is r square. This is r square. We'll use the Pythagoras theorem, r square plus r square under root. This will give you under root 2r. And when it reaches AC, what is the displacement? R plus r, so 2r. Again, when it reaches D, what is the displacement? Again, because this is r, we'll again use the same formula, and this will be under root 2r. When it comes back, it will be 0. Displacement will be 0, and distance will be total covering. So this is what is being shown here. Distance traveled by a particle from A to B is 2 pi r by 4 in the first case, A to B. And the displacement is under root r square plus r square, that is under root 2r. And from A to C, that is this point to this point, it will be 2 pi r by 2, because whole circumference is 2 pi r. So it will be 2 pi r by 2, that is pi r. Displacement is what? R plus r. This is from here to here, it is r. From here to here, it is r. So displacement is 2r. From A to D, that is this point to this point, this has to be taken totally. So this is 3/4 of 2 pi r. 2 pi r is the total circumference. So we have to take only 3/4. So this will be the path length, and displacement again will be under root r square plus under root r square, under root 2r. But at this final position, if we come back here, the displacement will be 0 and distance will be whole 2 pi r, which is being shown here. The path length will be 2 pi r, displacement will be 0, because the particle has come back to its original position, and because it has traveled totally, the path length or the distance will be 2 pi r. Average speed and average velocity. Why it is average speed and why it is average velocity, we'll know by now, after discussing this scenario first. Means when an object is motion from here, so it is moving. And how to know, and this is very important, that we need to know how fast is the position of changing of an object is changing from time, with respect to time. T1, the object is here, T2 it is here, T3 it is here. So the ratio of path length, that is the total distance from this, just add all these, to the time interval during which the motion takes place from T1 to T3, say. We know it as by average speed. We denote it by V, or a bar on a V. So the time interval, average speed is totally speed equal to distance by time. This you need to just remember. Speed is distance by time. Path length is total distance from this to this, and time interval is still from, say, T3 minus T1. So if an object travels, say, a distance delta x in time interval delta t, the average speed in this time will simply distance by time. V will be x by t. So now the question is again, how fast the position is changing with time, right? We have to define this with the average velocity. Average velocity is the ratio of displacement. Please understand, it is displacement by time, in which this time the displacement has occurred. So average velocity will be displacement by time, x by t. Average speed and average velocity, they have SI unit, meter per second, because meter per second is very small as compared to the large distances. We generally compute it in terms of kilometer per hour. And the direction is very important with respect to, or when we are talking about average velocity, because average speed, there is no concept of direction. So the direction has to be taken in certain signs. This is plus direction, this is negative direction. So we do not use the vector notation for velocity. We'll try to learn this with respect to vectors in coming discussions. Say if t equal to 0, the car start at A, it goes to B and return to C in 2 hours. So what is the total distance we have discussed? Say this is say 60, this is 40. So it is 100, the path length is 100. And the time as said 2 hours. So 100 by 2, that is this 100 kilometer, okay, 60 plus 40. and this is B, this is C. So it traveled to 60, then 40 came back. 100 is the total distance and divided by 2, which is hours, so 50 km per hour. But what will be the velocity? Velocity will not take the distance, will take the displacement. So from this point, say to this point to this point, say this was say 40 and this is 20, so 40 minus 20, it is 20, and 20 by 10 is 10 km per hour. And we need to understand about the sign of the velocity, because sign is very important. The sign says that the average velocity of the car is actually in the positive x direction. So now the car moves from ABCO and comes to O in 3 hours. Let us just assume that the distance is 140. That's, we say 140 by 3. That is 46.6. Now an object goes from this point and again comes to this point. It means it reaches ahead of it. So say this is 0, this is 20. So now this is minus 20. So average velocity will be 0 minus 20 by 3, say in 3 hours. So it will be negative. So average velocity of a car is in negative x direction. So the average velocity can be positive, negative or 0. Average velocity can be positive, negative, it is 0. It can be 0. So it depends totally on the sign of the displacement, and in general the average speed of the object can be equal, can be greater, or equal and greater than magnitude of average velocity. It will not be less. So what is the average? Average is why we are using average again and again. See, while you are moving, say from Ahmedabad to Vadodara. Now there is a very good road, there is an expressway. You went from here to here in say 80 km per hour. But at this point, from here point, there is a congestion. So you had your speed at 20. From this point to this point, oh, here also you stopped. Okay, you stopped for say 10 minutes to have lunch or your drinks. Then you reach here with some other speed. Now the total distance you traveled, you had different speeds. So we cannot have all these speeds. We need to take the average of this speed. So the average from A to say B or Ahmedabad to Vadodara, from A point to B point, is 50 km per hour. But though it is not representing the actual speed you maintained during the travel, because at some time you were 20 km per hour, at some time you were 80 km per hour. So when we combine then average them, then we say that it is some 50 km per hour. I hope you got the idea. So a vehicle's start or a vehicle travels different distances with different speeds in the same direction. Find the expression for the average speed of the vehicle. Please understand, we have been asked about the average speed. So suppose the distance the travel take is, this is d1, from here to here d2, like this. Okay. Now the speed it maintained at first d1 is v1, say d2 v2, like this it goes on and on. Now what will be the total distance? d1 plus d2 till dn. So d1 plus d2, d3 and dn. We don't know the distance, so we go up to dn. Total time, here t1, here t2, till time tn. So let us add the time, total time, but we know the speed equal to distance by time. That is time equal to distance by speed. So in this case, this is d1 by v1. So time first t1 will be d1 by v1. Again t2 will be d2 by v2. Like this it goes on. Average speed is what? Capital D by t. That is, capital D is simply the addition of all the distance, and time we just found out to be d1 by v1 plus d2 by v2 plus d3 by v3 till dn by vn. So if the vehicle starts or travels two equal distance, say d1, d2 equal to 2, means if we are here and here, this is d1 which is equal to d, this is d2 again equal to d, so both are equal to d, and see velocity v1 is maintained here, v2 is maintained here. So this is for d distance, this is for d distance. What will be the average speed? Total distance is d plus d, that is d plus d, 2d. And what is the average speed? This is t1 plus t2 in the denominator, and t can be easily obtained by d by v1 and d by v2. So we add them, d will cancel out. It will be 2v1 v2 by v1 plus v2. So average speed totally dependent on the velocity. A person walking in a straight line covers half of the distance to be traveled with a speed v0. For half of the time to require to complete the remaining distance, he walks with a speed v1, and for remaining half time, his speed is v2. What is the person's average speed during the complete walk? The question is like this. A person walking in a straight line, he covers half a distance. So d by 2 he covers in v0. And again, we have distance of d by 2 here in the second half. But in the second half, for the half means again d by 4. Right? It travels with v1 and here it travels with v2. Again the distance d by 4. So you have to compute the average speed. So let us say total distance is d. So half distance is d by 2. And t1 we take as the time which is taken by first distance to cover, and we take this as 2t. Why? You'll just know. This we took as t1, this we took as t2. Now we know that the distance is average speed into time. In the first case, the speed is v0 and the distance is d by 2. So if we take t1 as the time, so simply distance traveled d by 2 will be equal to v0 into t1. So t1 can be obtained by d by 2 v0. This is the first expression for this half. Now let us go to this half. And the next one, the distance we have just computed lines, right? Now the next one, this d by 2, total d by 2 is covered in how much? We say that this is 2t. Why we take 2t? Let us take this as t, this as t. But for the computation, d by 2 will be v1 into t plus v2 into t. So this will be v1 plus v2 into t. So what we got, 2t will come here and v1 plus v2 will go down. So 2t is d by v1 plus v2. So the total time travel is, we took first half as t1, second as 2t. So t1 plus 2t. So the average speed will be what? Speed we know, distance by total time. But t1 we have just computed to d by 2 v0 here. And second time is d by v1 plus v2. We put here. And this distance is total d from here to here. All the distance is d. So just we rearrange them, d cancels out, and this is the final value. So this is the first part of our discussion on motion in straight line. We'll be discussing this in another few sessions. Till then, thank you so much and take care of yourself.